Coming up on Astro TV tonight at 8:30, join Sun Hill Police in The Bill. At 9:30, our family movie featuring funny man John Candy in Uncle Buck. And at 10:45, that classic film from a Tolkien novel, Lord of the Rings. All that and more coming up on Astro TV. Greetings, the Astro 30 here, and I'm doing another video series on designing something electronic to the final product stage. In this video series, we're going to be looking at an audio input selector. Now, that's basically on an amplifier, selecting your video, your CD, DVD, all those audio stereo inputs, for instance. And before we even get anywhere near designing anything, we need to know the basic criteria that we need to achieve. So in my circuit, I want it to switch 4 inputs. It must have a tape in, tape out. Now, tape decks aren't used that much anymore, but it's always handy on an amplifier to have the tape out sockets there, which just basically come off of whatever the source is selected. So the tape out must be the tape out must follow source. And basically the tape in will remove the source from the preamplifier and bring the tape into the preamplifier, but not allow the tape in to go back into the tape out, basically causing feedback. That was basically what that means. It must be minimal BOM, or bill of materials, so must use minimal components as possible. Like, we don't want like hundreds of resistors on there when it can be refined down to using like 2 resistors to do multiple things across the board. It must run on unfiltered AC secondary voltage. So you're not bringing it off the DC power supply of the amplifier supply rails. It's coming directly off of the, well, basically the windings of the transformer, so to speak. And depending on the method you'd use to switch the inputs, in my case I'm going to be using relays because they're simple. You will need some form of filtration to stop the possibility of the relays from chattering, because they don't like running on unfiltered DC. So it must run on unfiltered AC secondary voltage. It must have LED indication of selected channels. And, well, the reason it was running on unfiltered AC secondary voltage or unfiltered DC is so that with the LED indication, and possibly the relays as well, they'll instantly go off when the power switch is turned off, so you don't see an LED still lit on the front panel and it slowly fades out, because that can look annoying after a while. It must be panel mount. So all the RCA sockets all mount to the PCB, and the PCB mounts to the panel via the RCA sockets. And it must take up minimal space. So if we keep these criteria in mind, we should be able to come up with a circuit that meets all this criteria. So let's look at drawing up a basic preliminary circuit that we can go by. Okay, so I'm going to start with the easiest. I'm going to start with the voltage input, so I'll call that VAC. Now it could already be a voltage coming off of a full wave rectifier, for instance, that hasn't got smoothing on it. Like on my previous design of that speaker protector, I had a full wave rectifier for the loss of AC detection, and it was unfiltered, and it's also powering an LED. I can have another plug hanging off that to give me the 25 volt unfiltered AC coming into this circuit, for instance. So we'll do that, but in the meanwhile I will add a diode, for instance, and basically this diode will only allow, well, positive to flow into the circuit, but it'll also isolate the power supply circuitry from this circuitry. That'll basically stop the cap discharging back into whatever it's connected to, so because that'll defeat the purpose of having an unfiltered circuit at this end if there's a filter cap at this end. Anyway, that's getting ahead of ourselves, so I'm going to rerunning 12 volt relays. So I'm going to come up with a very simple regulator, shunt regulator circuit. So we've got a 1K resistor and a 12 volt Zener. We take the center point here, that's now going to be our plus 12 volt rail. That's fine. So now, in the interest of saving part count or keeping the bill of material down, we're going to have several switched inputs here, and it's going to require 5 relays, 4 for the source inputs and 1 for the tape input. That's unavoidable. So I'm just going to draw one relay circuit for now because we don't really need to see all of them. So we're going to have a switch input, which is coming off of our rotary switch, and we're going to put it through a dropping resistor, we'll say 10K, and that's going to go into the base of a BC549. That's going to go to a relay coil to the plus 12 volt, and of course we're going to have our flyback diode there, which is also a 1M404, 4004. That's fine, and that'll work just fine. But how about LED indication? Well, you could, and don't forget we're going to the switch, we also have a plus 12 volt going into the switch. With the LED, we could simply on the separate switchboard, because it's going to have 2 circuit boards in the end, one where the rotary switch is mounted to and the LEDs for the indication, we could put our plus 12 volt out to the switchboard. We could switch on one side of that switch, if we use a 2-pole switch for instance, one side of that switch could be switching 4 of these transistors, and the other side of the switch, the other pole, could be switching the LEDs. That's okay, but you're still going to need an extra resistor as a dropper for those LEDs in the commons. So I'm thinking the easiest alternative would be to pass this voltage coming in from the switch through an LED, through the dropping resistor, into the base of that transistor. Okay, that means now we're going to need 4 resistors per transistor, or do we? We can modify this even further, and we can just simply go straight through an LED, and where we're going into the switch at the center, the common, we go through our dropping resistor first. So the dropping resistor comes into the switch, and then it passes out the voltage, dropped down, passes it through the diode, or the LED should light up and pass current, allowing the transistor to turn on, turning the relay on. If you really wanted to get real anal, you could limit it to one transistor on the switchboard itself, and then just switch the collector out to, you know, your different relay coils. But then you can't have the LED passing through in series with the transistor then. Because we're already dropping the voltage at the base via that dropping resistor, and well, you need a dropping resistor for an LED, so we'll put the LED in series. Thing is now to actually test to see whether or not this circuit will even work. It may not. So I'm going to build up this part of the circuit first, and I haven't forgotten, but we are going to need some form of filtration there, so it won't be exactly instant off, but it's close enough. So we're going to have like a 47 microfarad 63 volt there. I mean, 63 volts overkill, 16 will do. But if this diode goes short circuit, for instance, it's going to pull the full 25 volt minus the drop of the 1K there onto that cap, which won't make it very happy. That's assuming that this diode ever shorts. However, let's breadboard up these two circuits and test them individually and see whether or not they actually work. Okay, and a short time later I've got my little circuit built. I've got the shunt regulator, little filter cap here. That should have been after that shunt regulator, but for all intents and purposes it doesn't really matter. Got my power supply set to 25 volt DC, which is roughly what's going to be coming into it unfiltered. Now, I'm going to measure at this point here, which is the positive rail form between the cathode of that Xeno diode there and that 1K resistor respectively. And we're going to have a look on the meter, if we can see it. I can't see it in the viewfinder, but it should be seen. So I'll turn the light on. Nothing went bang. We're currently sitting at 11.71 volt. Don't know if you can see the meter, but it does say 11.78 volt, close to 12. So that's fine. So now I can connect up my ground wire to the emitter of the transistor, which is not connected yet, and connect that over to a suitable earth point. I might use this wire. So I know it's red and it should be a different colour, but it doesn't really matter. So that goes over to here, which is our common ground. The other thing is, I'm not sure how this relay works because it's got two pins either side of the coil here, and I'm not sure exactly why. So what I'm going to do is I'm going to go into continuity mode here, disconnect that. I'm just going to see if those two pins are actually physically joined together anyway. Apparently they're not. No, they're not. So I'm not exactly sure what they're for. I could look it up. That's 0.6 kiloohm, about 600 ohm there, so that must be the coil. What's this then? That's also 600 ohm. Seems like it's twin coil. Not sure why you would have twin coil on there. I'm just going to quickly look up this particular relay and see why there's two extra pins for the coil. That might be because these are probably latching relays, hence the two coils, instead of just a standard DP-DT relay. So I don't know if this particular relay I've got here is going to be any good. So I need to connect it up to the power supply. Well, the power supply for now. So I need another jumper cable. So if I connect that to one coil, connected to the positive, and then this side, which just came back off, you stay on there. That one to there, turn the light on. Okay, so that didn't actually activate. Yeah, it's a latching relay. It didn't unlatch until you do that. Oh well, so I got 5 of these and they're no bloody good. I think I do have a kit with these smaller relays in them. I'll see if I can find it. I'm going to have to order some online by the looks of things, because this is not the right part number. These were in the wrong box at JCar, so they're not right. Okay, give me a sec. So, say hello to my little friend. Luckily I've got a relay that should work. So I'll connect this up. Okay. So now I'm going to connect that to the transistor, and the relay is currently off. We're drawing no current, so I just need a wire to simulate the switch, and that just gets touched to positive volts, and look at that. The relay comes on, so does the LED. We're still drawing about 20 MA. The LED is not awfully bright. That 10K could probably be lowered. 10K is probably a little bit high. But it is driving the relay. The relay is turning on and disconnecting. So the whole entire point was to, as soon as the power switch was turned off, the LED would go out, which it does, but there is a slight little fade out there. But that's not really a problem. So my basic design did work, and effectively it doesn't matter where that filter cap is. It could be there or it could be there. It's still going to have a slight delay turning off, or fading out, should I say. And yeah, that works very effectively if I get my hand out of the way. Okay, well that was pretty simple. As I say, I'll order the proper 12 volt relays. I might be able to get them from JCar online anyway. I'll just type in the catalogue number and yeah, get the correct ones. Those latching ones are going to be absolutely no good. So we've fulfilled most of our criteria. We have it running off of unfiltered DC, off of a transformer, although it's using on a DC power supply, but it's mimicking a transformer. It will work the same way. We've limited the amount of components needed. We don't need like 4 or 5 10K resistors to bias this in the transistor circuit here on the base. We can get away with just one on the switchboard itself. Assume this is the switchboard side, and that's the main PCB side, and the LEDs are mounted on the same switchboard. And the same also goes for the tape monitor input. However, that's a separate switch from the rotary, so you'd have to have the switch going into the switchboard, then coming back into here. We'll get to that a little bit later in the design. But so far, that's working. And to complete that off, you would have your relay contacts for each relay. Say connecting this to RCA sockets, left, right for instance, and these would all join together with every relay, but they would then go off into the left and right preamp out, or to the input of the preamp. And that's how we would make that little switch circuit. So this little circuit here with the transistor, the diode and the relay will be duplicated 5 times. 4 relays for each of the source inputs and 1 relay for the tape input. And the contacts of that relay for the tape monitor section have to be treated a little differently. Yes, you are connecting the input up to the preamp out, but you're also disconnecting the source from the preamp out, and you're allowing the connection to go through to the tape out. But the tape out would just come off of, well, these 2 lines, and then the tape monitor relay contacts would be switching this part before the preamp. So it would be switching in these lines to the preamp when it's not in tape monitor mode, and when it is in tape monitor mode, it'd be switching these lines out and bringing in a separate tape input into the preamp out. It'll all make sense in a final schematic. But for now, we know that the driver circuitry is working. We can have an LED in series with the base of the transistor, and both work happily well together. I would suggest using high intensity LEDs like blue LEDs, not your standard 20 MCD red LEDs, because they won't glow very brightly, and you don't want to have this resistor any lower than, I'd say, 4K7 on 12 volt, just to be on the safe side, because those red LEDs require 1.2 volt to operate. The blue ones require 3.6. So you don't want to exceed 3.6 volt at this point here. And you really don't want to saturate this transistor hard on if you can avoid it. It doesn't have to be any higher than 0.6 of a volt. But that's my preliminary design. It works. Thing is, that capacitor's in a different place. Well, we can fix that now. We can just put it there instead. Same difference. That's a 1 watt device, and so is the Xeno diode. So now we can move on to actually, well, looking at a full drawn schematic, going through that, and then think about making a circuit board. Now, this particular project should not take as long as that speaker protector did, because it's not as involved. It's simple as bat piss. SOS. No. Okay, and this is the completed schematic, drawn out and everything. It's 2 separate boards, the main board over here and the actual switchboard over here. So let's just start over the top right here. As we can see, we've got 25 volt and ground or 0 unfiltered DC coming in. I know I did say AC in the beginning of this video. I meant rectified unfiltered DC, but because there's already a diode here, you could use 25 volt AC from the secondary of the transformer. It really doesn't matter. That then goes through this diode, as I said, which is forming a half wave rectifier, and if I was to use DC instead of AC, it'll only allow the positive to come through, so if it was connected the wrong way around, it's not going to damage anything. This then going through C1 here, which is a 10 microfarad at 63 volt or 50 volt, and that's just providing basic filtering. Now the breadboard design is 47. I changed it to 10 microfarad. I'll have to test it properly. It may have to go back up to at least 22, not sure yet. Then we're going through this 1K 1 watt resistor and this 12 volt 1 watt Xeno diode, which is forming a basic 12 volt shunt regulator, and this line here is a plus 12 volt rail. Then we look at this switchboard. VCC is plus 12 volt. We're coming in from the 12 volt rail in through a 10k resistor into, I've marked this as position A. On the actual board it's going to be position C, just the way the the routing is done to make it look, well, make it easier to route. For all intents and purposes, it doesn't really matter. And that's going through a 4-position, 4-pole or even 3-pole, 4-way switch. I'll show you the switch in a minute. And each of these switch elements goes through a separate LED forming A, B, C and D. T is different. That is joined off of the VCC here to TVCC, so this is a separate connector. And then you've got T in back from, you'd put a switch like a SPDT switch on this these two lines here, and basically when that's switched in, that goes through this 10k resistor through this LED off to the T line, which is the tape monitor switch, tape monitor LED, which joins up to each of these driver circuits. Here we've got A, B, C, D and T, and each driver relay. So if we look at just the T line, it doesn't really matter which one we look at. From that board we come into the base of this BC549, which is switching the earth or the ground up through the emitter, through the collector, through the relay coil, up to the 12 volt VCC line with a back EMF diode connected in reverse polarity to the actual current flow, which will prevent any huge voltage spikes as the coil collapses, the field of the coil I should say collapses, and doesn't end up inducing it back into the transistor, destroying the transistor. Hence the term back EMF. Now each of these relays has its own set of contacts. It's DP-DT, so this is contact set 1, contact set 2. So A, B. That's why it's marked switch 1A, switch 1B. But they're part of the relay contacts, as it says, RLA1 contacts. Where the switch line is drawn closed, that's normally closed position, and the open ones is normally open. So we're switching in our RCA sockets for the left and right for video, for instance, through the normally open contacts coming out the commons. Down here we've got our final 4th input auxiliary, which is switch 4, relay 4. That's then coming into this set of contacts, which is relay 5 for the tape monitor. Now this is actually drawn backwards. This line should be here and that line should be there. Conversely, that line should be there. This line should be there. I've drawn them around the wrong way. This is normally closed. This is actually going off to the tape input RCA sockets over here, which is wrong. The normally closed positions should be joined to the commons of these other 4 sets of relay contacts on the A and the B side respectively, and the normally open ones should be going to the RCA socket for the tape in. So it's drawn backwards on the schematic. I've noted that, and I will correct that before this schematic becomes live. Mistakes happen. Down here we've got our tape out RCA sockets left and right, and all they do is join to the commons of each of these sets of relay contacts. So contact 4, 3, 2 and 1 respectively is all connected to the tape out. So the tape out is following the source input, so whichever one of these is switched in will be routed to the tape out. So we've fulfilled the criteria on that part, that the tape out must follow the source, and because the switching of the tape relay is done separately from the rotary switch, that is, that if this switch is switched into, say, the B position, it will stay switched into the B position. That means Q2 and RLA2 will be turned on, therefore connecting the, in this case, the CD inputs in through to the preamp. When the tape switch is switched in, so the T line is now active, both B and T will be on at the same time. So you'd have that LED illuminated, that LED illuminated. However, when T is switched in, basically now the output is removed from the B line. So here is RLA2's contacts. These two common points will now be switched out of circuit by this relay if it was drawn the correct way around, and then allow the tape in inputs to come out through here. So these remain switched in, but they're not connected to the preamp anymore, but yet it's still connected to the tape out. I know that convoluted description was a little bit hickledy-pickledy, but basically these switches stay switched in all the time, and this one just switches between either these switches or the tape input respectively, and that's all that does. And tape out follows these inputs. So that's the complete schematic. Now it would be time to design and make a board. And here is one I prepared earlier. Actually, I spent all of Sunday doing this and didn't make a video on Sunday, even though I wanted to. Now, we can't see much on this printout because, well, I've got the overlay and the copper side all printed at the same time. But we can see the board is relatively small. It's not as small as I'd liked it, but that's because we're using PCB mounted RCA sockets and PCB mounted relays, and it's single sided, so you're sort of limited to how small you can make it. But it's relatively small. So here's the overlay diagram. So the copper side is dulled down so we can see the component side a bit better. We've got our 5 driver transistors, 5 back EMF diodes, 5 relays, our power supply section over here, and our audio output section there. Down the bottom here we've got a simple switchboard. We've got our rotary switch mounted to the board, 5 LEDs. We've got the switch input here which connects to here, and we've got this tape input here which is going to your tape monitor switch, which is separate from this board. And you may notice that there's a lot of white space between the edge of this connector and the board here. There's a reason for that, because in the final design it'll be using some of these. These are right angled locking header connectors, and I did it that way because when these stand up they're a good, I don't know, almost 15mm high with the connector alone. With the plug plugged in, it equals nearly 20mm sticking up. Now remember, this board is mounted to a front panel, therefore there's limited space guarding the height of this switch. So whatever the height of this switch is the amount of clearance you've got from the front of the circuit board here. So having a horizontal, or I should say vertical mounted at 0 degrees header connector is not going to work unless it was mounted to the back of the board, of course, and on single sided circuit board that gets a little messy. So using a right angle connector like that means it plugs in from the side and you have a clearance of about 6-7 mil. So that's perfectly fine. Now onto the switch that I was going to be using. This is the type of switch I'm talking about. It's just your standard 4-pole, and this is set to 3. These are physically adjustable, how many clicks they've got, so you can adjust the click stop. So all we do is we get a pair of pliers, we undo said nut. You don't have to take it off all the way, but for the demonstration purposes on video I'm going to take it off all the way. This is the switch stop locator, I'm not sure, well, it's the switch stop anyway, and it has round the outside here, it got 1, 2, but there's no holes for it. Then it goes 3, 4, 5. So you can make this either a 3, 4, 5, 6, 7, 8, 9, 10, 11 position switch. Now if you're making an 11 position switch, you're actually joining 2 of these poles together. So that becomes one whole switch in the end. You've got to keep that in mind. But if I want to turn this into a 4-way, all I do is move that stop from where it was, which was there, along one, drop it in, and put all my mounting hardware back on. And we have 4 separate poles, so we have 4 separate switches. And there we go, there's the 4th position. So we got 1, 2, 3, 4. That's it, and that's how you adjust those. So that's the type of switch I've gone for, and that's what's going to be mounted to the front board there. So, next thing to do would be to stop talking about the bastard and actually make up some circuit boards. Now, I haven't forgotten about that speaker protector project. It's just a little bit more involved laying out a circuit board for it, and is more time consuming for me, and I haven't done it yet. I will do that. I haven't forgotten about that project, and the same goes for that sub-bass preamp controller, EAS, whatever you want to call it, in that rack case. That project hasn't been forgotten about either. I just haven't got any motivation to work on it at the moment, because I'm up to the hardware stage of drilling holes in things, and yeah, I'm not really all that motivated to do it. So anyway, moving on to doing the circuit board. I don't have all the parts. I'm still waiting on some RCA connectors from China, some relays from China. I did manage to get 2 relays from JCar. And I'm also waiting on some LEDs, some blue ones. Now I've got some, but the shafts, not the shafts, the legs are not long enough. And the reason I say that, they're not long enough to clear the total height of this switch. Plus the top of this shank. Now when I say that, in the final mounting of this, there'd be a sub panel behind the front panel, hiding all this mounting hardware, so I've got to overcome the distance of the sub panel to the front panel to the top of the shank. So the LEDs I've got have only got like 25mm long leads on them. They're not long enough. I've got some coming on the way with, I think it's 35-40mm leads on it, which will just be long enough. But they're also high brightness according to the description, so I don't know whether or not my original breadboard design is going to be work sufficiently with that 10k resistor for the dropper, or I have to change it, or they're going to be the same brightness as the others that already I tested it with. That remains to be seen. As it is, it's not bright enough, as we saw. So, without further ado, let's get these boards etched and drilled, etc., cut to size. It'll take me a good couple of hours to do, and then we can think about mounting some components. So let's go. Okay, I've just found out something interesting about these relays. Works that way around, but if I reverse the polarity, nothing happens. Well, that's fairly interesting, because I reckon these type of relays already have an internal back EMF diode. So that actually gives these relays a polarity. And I found that it should be from the top anyway, that way around. So my board, if I was to use these relays, is wrong, because I got the positive coming in over here where it should be the negative. So that kind of makes these back EMF diodes here on the outside redundant, but there's nothing wrong with having them there. So I'm going to have to reroute the board to suit these relays. And I'm just hoping that the Chinese relays that I've ordered are the same. I can always test that, and if I have to, I'll go to JCar and get some more. I didn't realise these actually had a polarity, but apparently they do. There should be a data sheet for this particular relay, so I might have a look. Right, I had a look at the data sheet for this particular relay, and it does say pin 1 from the bottom view, which is down in this bottom right here, is marked positive. That one's marked negative. So when I turn it over, positives over this side. No, negatives over this side, positives over that side. I've got it marked around the other way on this particular diagram, so I'm going to have to change the routing, which is not that hard. I just move this line from there to there, and then move that line from there to there. The relays I've ordered from China I don't think have a specific direction. I'm just going to double check that before I commit. Right, now according to the data sheet for the HK19F, which is the type of relay that is, there is no specific polarity to the coil, so it can be connected either way around. So I'll make the best of both worlds and make sure that this pattern will fit both types of relays, because they're going to be different types. I mean, I'll probably end up going to JCar when they've got more of these in, or go to the Derwent Park store one anyway, and get 3 more of these so they're all the same. Doesn't really matter. Anyhow, I'll just make the quick change to the circuit board. I'm not going to change this overlay right now to save some time, but I will just correct my routing and get started making a circuit board. Okay, I've just spent the last 4 hours marking around and haven't achieved anything. This switch is not going to work. This 4-pole switch has a maximum switching positions of 3. You cannot, no matter where you put this stop ring, it'll only allow three positions, and as soon as you exceed the 3rd position, it'll just start going back to the 1st position again. So you'd have like 1st position here, the 2nd position, 3rd position, and then the 1st position again. So this switch is not going to work. However, the 2-pole version can switch up to 6 positions, and luckily the pinouts are the same. I'm using common pin C, and it switches between pin 7 and pin 10 for the 4 positions once you've set this ring to 4. So if I set that all the way to fully anti-clockwise, we should now be continuous on pin 7, which we are. Rotate it 1, pin 8, rotate it 1, pin 9, rotate it 1 more to the final, pin 10. So if we look at our overlay here, this is pin 7, pin 8, pin 9, pin 10, a common. So this switch will work wherever, whatever I've done with it. Seems to have sodded off on me. But that switch will work fine with this overlay. I don't have to modify this board at all. And that's funny that I just had the switch a few seconds ago and now I've lost it. I just put it down and it's gone. Anyway, I've got 3 more of these relays. These are SY 4059s from JCar, and the switch is SR1212. And once I figured out where I put the switch down, because all I did was just disconnect the wire and, oh, there it is. Yeah, this is SR1212. I haven't done the circuit boards yet. I'm going to. That's the next step, is I've now corrected this board, as I said. That's all ready to go. I might expand the negative lead here so we've got 2.5 and 5mm spacings respectively for different size capacitors. So I'll do that, make the board up, and yeah, I'll come back when I've got actually some progress. Okay, and a few hours later, probably about 3, I've actually got the boards manufactured, etched, etc. Some of it's a little bit, yeah, how you doing, but it does the job, and every component fits, bar 2. No, I didn't properly measure that before I committed. The same with the audio output on this side, which is a 3-pin header of the same type, won't fit either. The 2-pin headers do. So the solution to that, well, for the audio output over here, I can just use a single inline header. They have the same pitch pattern as that. So that'll solve that problem. As for the 6-way, just wire the cable directly to the board, and the same on the other end here. So that's a bit annoying, but yeah, shit happens. But the boards are manufactured, and now all I've got to do is assemble them. So the next thing I will do is I will assemble this board as far as the switch, the 2-pin header, and that's it. I'll leave the resistors off until I can finalise what value they need to be, and of course the LEDs have to be left off because this has to mate up to a front panel, and we want to get the LEDs the correct distance away from that front panel. So that would be the last thing to solder. So I'd have to make up a test jig to actually test this circuitry on a piece of breadboard, just to mimic the switchboard. Not a great big deal, but yeah, so I'll get doing that and we'll come back. Okay, both circuit boards are assembled. This is not being used at the moment, so it can just sit over there somewhere. I've got the switch wires hooked into this piece of breadboard here. Drop a resistor. This is the VCC, the red one coming in, and this is basically mimicking the switch. All I've got to do is touch this wire to each of these anodes respectively to connect power through, and a relay should turn on. I've got the power supply set to about 17.2 volts. We'll leave it there for now. Load is off. Load is now on. So if I now touch, say, this LED, well, the LED came on. Except no relays are coming on. Really? So I'll see what voltage we get between negative, if I've got a good place to put it. Yeah, the cathode there. I mean yeah, whatever. 16 volt coming in. 6 odd volt coming out. Okay, power supply wasn't high enough, so now I'm at 21 volt, and now I've got 8 volt. Okay, it's enough for the relay to turn on anyway. So, doing the test again. That's one off, another one came on, next one came on, next one came on, and the first one came on. And if the tape monitor, which is the far one, was to be connected, now that's not quite enough voltage there, so I need another 10k resistor. So I'll find another 10k resistor, run up the voltage to 25. Alright, so we've got another 10k resistor, which I will just prop off of that point and that point. That's why we use two separate resistors. Still won't turn on. So what's our voltage now? So it's dropped down to 6 volt. Well, that's annoying. It can't drive two relays at once. Okay, so we found out one thing. Even at 29 volt, we're still not getting enough drive voltage to supply the 12 volts successfully to two relays at once. So yeah, that's not going to work very well at all. I'm kind of extremely disappointed, to be honest. That should have worked out perfectly, but it didn't. And yeah, looks like I'm going to have to go back to the drawing board on that, because, well, if it doesn't work, it doesn't work. I mean, there's nothing wrong with this particular switchboard apart from that fuck up there. Albeit the rest of the relays do actually engage with each channel, but I'm just not getting enough current across that Zener. Okay, I've got a 15 volt Zener in there now. I haven't trimmed the leads off. I'll leave them as long as possible for now in case I want to remove the Zener again. So I'll just plug the power wires back in. Now, power it back up. Still at 25 volt. Well, nothing untoward happened. Relay's working. Nope, still no dice. So this circuit is a complete and utter failure. Complete failure. Yeah, we're lucky to have 6.2 volt there. That's ridiculous. Yeah, there's now 9 volt there. As a regulator, this is not working out too well. Just going to try an experiment. It looks like I'm going to have to remake the board anyway. You know, this is one of these situations where you should have tested the circuit out properly first before committing to a circuit board. I've just wasted material now. So what I'm going to do is I'm going to stick a capacitor across, well, if I can. That comes across there, so that's the negative there. So basically I'm sticking it across the Zener. So I might do it down here. Okay. I'm just only going to tack it on because it doesn't really need to be there permanently. It just needs to be there to function. Because what I'm thinking is there's not enough bulk capacitance there across the output, maybe. Okay, now I've got no power at all. Well, that's interesting. We're still connected. I'm connected the right way around. Alright, so I'll leave that disconnected. What's the voltage out across that Zener now? Nine volt. Okay. Now the voltage is 6.2, so it's barely enough to turn that on. Keep losing power here for some reason. Got a dicky wire by the looks of things. Yeah, that does work. At 25 volt input, which would be unrectified DC. So after rectification, well, unfiltered DC, so after filtration it should be somewhere more around the magnitude of about 30 volt. So I'll leave it at 30 volt. That seems to be about right. And we've got 7 across there, so yeah, it looks like I need a 15 volt Zener and a capacitor on its output here. Now, because the board is wrong anyway, because of this connector over here, which is not a connector, I really want to make it properly, so I can take the relays back off, that's not a problem. The 15 volt Zener. So what I need is a smoothing capacitor on the input and one on the output, and yeah, so that is functioning, albeit not quite the way I wanted it, but this is what happens when you design something, you make the board, and this is exactly what I was talking about. This sort of crap happens and it doesn't work correctly. So I need to go back and redesign it. Yeah, I wasted a piece of PCB which cost me about, you know, for the whole sheet, 20 bucks. But I did notice that the reason why the developer is taking a hell of a long time to develop is because I'm using tracing paper to expose the image through onto the board. And I noticed it was developing around where the paper was sitting a lot quicker, and I could see the copper bare straight under it pretty quickly within about 30 seconds. So that's a good indication that maybe the tracing paper idea is not a good thing to do it anymore. What I might do is I might actually put a proper voltage regulator on there instead, a 12 volt one. Yeah, just to make sure that there's plenty of voltage at the output. Add an extra capacitor at the output. Yeah, you're going to have not quite a instant off delay, but it's quick enough. So we've got 47 microfarad there, which is going to be our filtration capacitor, and another 47 microfarad over here as the bulk output capacitor for the regulator, and just, you know, rejig the board a bit and fix up these connectors which are completely wrong. Okay, you live and learn. I'm still waiting on the input sockets anyway, so yeah, well, I'm getting new relays anyway as well, so I can leave this in one piece. It's not going to do it any harm. So yeah, as far as I know, I've got this all wired around the right way. Well, if I'm coming from there, that's number 2, so that's going right over to... Actually, number 2 is the tape monitor input, so I've actually got this backwards anyway. That's the actual tape monitor there. This is the inputs. But it still works, so there we go. So this is actually our tape monitor. With that relay off, that would be our source inputs here, so that would make mean that all the commons from the input should actually be connected to the normally closed position of that relay. So if I look at this on continuity mode, so we've got an input here. Which input are we switched on? I think it's this far one, so this one here. That should be coming out the COM, which it is, because that's normally closed there, so that's normally open. That's now coming out to the preamp out on there, so that's wired correctly. And as soon as I put the tape monitor on, we've got continuity there, no continuity there. But now that's the tape out. Tape in comes here. That's now connected to the preamp in on both sides. So at least that part of the circuit is functioning. That's the main thing there. So I know that tape monitor loop is correctly wired and routed, or whatever you want to call it. So that just means now I've got to fix up, well, my fuck ups. Let's face it, I'm human, I make mistakes, I waste material just like everybody else. It's no great big deal, just, you know, remake the thing and move on. We'll continue this design on a little bit later. I'm going to end this video here, and I hope you enjoyed it. I enjoyed making it, although I've made mistakes. Other things are going on around here which are not working either, which is starting to piss me off, but it is what it is. Anyway, I'm the Astro30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyhow, this is the Astro30 saying, see ya, happy input switching.